Hello, my name is Srivathsan and with me is Nagaraj. Both of us are part of Intuit's data platform. We are going to present SpoK, Intuit's implementation of Spark on Kubernetes, and how that has enabled us to scale our big data processing. To give a brief overview of Intuit, we are the makers of finance and accounting software such as TurboTax, QuickBooks, and Mint. Our products serve the financial needs of consumers, small businesses, and those who are self-employed. Intuit's mission is to power prosperity around the world with AI-driven expert platforms, and that mission has never been more important than now. Powering Intuit's mission are the financial data sets from various Intuit's products. All of this data is organized in Intuit's data lake, which has upwards of 7 petabytes of data in the lake and growing. Overall, Intuit's platform manages over 40 petabytes of data across our products. In order to process these data sets, we leverage AWS EMRs, spinning upwards of 7,500 EMRs every day. These EMRs use over 50,000 EC2 instances purely for data processing purposes. In addition to EMRs, we also use other AWS services such as SageMaker, Athena, S3, and Redshift, and perform a majority of data processing using Apache Spark or Apache Beam. The data processing infrastructure is crucial to power Intuit's data and ML platforms and pipelines. This Spark plus EMR ecosystem powers the ingestion of data into the lake, curation into well-defined datasets, and exploration for analytical purposes. Furthermore, this infrastructure also powers ML pipelines from the same datasets, processing of features, training and evaluating of ML models, and performing inference for predictions in our products. And these are the inferences that power the AI-driven expert systems that Intuit is building. With such a large data processing footprint, it becomes crucial for optimizing the development and deployment lifecycle of a data processing code. In order to enable that, we have a paved road built around native AWS services for data processing. At the same time, Intuit has also invested heavily on a paved road for services development, which is based on Kubernetes, Argo CD, Argo workflows, and other cloud-native technologies. The services paved road also encourages GitOps and other modern development practices. We wanted to leverage the power of cloud-native technologies for data processing. And that's how SpoK was born. While we were extensively using EMR and Yarn, we were very interested to integrate with the existing Kubernetes infrastructure in the organization. We liked containers over bootstraps scripts that we were used to in EMR world. Kubernetes as a resource manager as compared to Yarn. We also wanted a modern continuous delivery process for data processing jobs. Let's dig deep into each one of the above in the subsequent slides. Services within Intuit are deployed and managed on Kubernetes. The Intuit Kubernetes service, shown some of the UI elements are shown here, allows service developers to manage their service runtime and deployment. Since Intuit already uses Kubernetes at a large scale for running a majority of our online services, here was an opportunity to have a single resource manager to manage both service and data processing workloads. This would help immensely in the management of infrastructure, reducing costs, reducing operational overhead, and automation across the organization. Containers for data processing jobs are extremely useful because it helps data workers write their code once and deploy it across environments in a standardized and a very predictable way. This becomes extremely important in the cloud where your dev environment and test environment and production environment are quite different. This approach combined with the declarative management of Spark jobs means no more complicated shell scripts to manage. As you can see here, you can see the containers that are being deployed declaratively, and our earlier systems where we used to manage these deployments using numerous shell scripts that were um, orchestrated via the bootstraps of EMRs. The other big aspect is around scheduling. So Kubernetes is a general purpose scheduler, which is widely used and adopted in the organization, whereas Yarn is a specific scheduler for managing data processing jobs, which requires a lot of expertise and thorough knowledge. Earlier, it had taken us a long time to fine-tune Yarn scheduler for its load balancing and queuing capabilities to achieve maximum efficiency out of it. Given that it is quite complicated and it is hard to find experts who are really good at performance tuning Yarn, it becomes difficult to manage large installations based on Yarn. So Kubernetes was extremely powerful choice for us because we could use the same advanced scheduling capabilities of Kubernetes to run data processing workloads. The other really important aspect for any software development is the continuous deployment. Data processing jobs are no different. They need to have really well-defined, predictable, modern CI/CD pipelines in order to power faster build and deploy cycles. This improves the developer productivity and also improves the quality of production releases. SpoK makes it easier to use the industry standard continuous delivery tooling for data processing workloads. At Intuit, we use Argo CD as an operator to manage Kubernetes resources and as the continuous delivery platform for data processing applications. Earlier, this was very cumbersome due to the complicated shell scripts and multiple sets of imperative commands that we had to use in order to deploy the applications and to monitor status. Here is a CD workflow taken from a real in production application where you can see the commit from the developer going all the way to production in a fully automated continuous delivery manner. To talk about the rest of the how SpoK was implemented and the internals of SpoK, I invite Nagaraj to continue with this presentation.
Thanks, Srivathsan. Thanks for the introduction. So this is a Kubernetes native workflow that we have here. And this is an end-to-end view of what a data worker interacting with the data processing infrastructure experiences. The data worker does data exploration using Jupyter notebooks, and once happy with the results, commits that to Git. Then primarily using the GitOps deployment model, this code is pushed to the different environments. And for that, we use Argo CD and Argo workflows where required. As part of this deployment of Spark operator, we have also have enabled Hive Metastore, which talks to a centralized Hive data store database to manage metadata about the data which is stored in S3, which is Intuit's data lake. Along with that, we also have the Spark history server deployed, which manages the history of the Spark processing jobs. And driving all of the Spark processing in the Kubernetes is obviously the Spark operator. The Spark operator, there's one single installation of Spark operator towards in the entire cluster, and it manages namespace across it, all the namespaces across the cluster. In future, we plan to host it outside of the Kubernetes cluster so that we can manage Spark jobs across multiple clusters. The deployment model for data processing jobs reuses the capabilities the centralized Kubernetes platform in the organization provides. The centralized Kubernetes platform in the organization provides some of the key capabilities such as self-service namespace creation and management, the authentication and authorization into these namespaces, the tools for alerting and monitoring of the resources which are launched within these namespaces. Spark operator is another deployment in one of these to manage the namespaces across the cluster. Next, we will walk you through a use case which has been enabled using the new Spark on Kubernetes infrastructure that we have talked about. QuickBooks is one of the flagship products of Intuit, and transaction categorization is one of the key features within QuickBooks. This transaction categorization helps users understand their banking transactions better. If categorization is done right, this could provide critical insights into the earnings and spending patterns of the user. And that can be a very handy information for the user. And the challenges with categorization of features is a similar transaction could be of different category based on the user, especially on the persona of the user. For example, above is an example of a home improvement transaction. A contractor would categorize it as materials and supplies, but a retailer might categorize it as repairs and maintenance. So in summary, transaction categorization becomes a personalization problem. To help with this, the model needs to be trained to understand the categorization preferences of the user. This requires feature extraction per user based on their transactions and their categorization history. All this is done as a data processing job running on Spark. And this is an example of the Spark job. So it combines transactions and the user's behavior to produce some features for that user. The previous feature extraction job for transaction categorization uses Argo CD for continuous deployment. This follows the GitOps deployment model. All the resources required for the job, such as the Spark role, the Spark history server, the actual scheduled Spark application jobs, are managed as native Kubernetes resources, and Argo CD makes sure to keep them up to date with what's required or what the data scientist wants it to be. This simplifies infrastructure management, as the data workers just need to specify that in a declarative YAML what needs to be done rather than having to deal with shell scripts or imperative commands on how things needs to be done. We had to build additional capabilities in addition to deploying Spark operator within the Kubernetes cluster. Here are some of the learnings having gone through that journey. We had to set up an Hive Metastore service, which connects to the centralized Hive Metastore. We had to package Hadoop AWS jars, which is not part of the standard Spark image. And we had to get it working with S3A file protocol as to interact with the object store S3. One of the critical challenges that we faced was getting Spark 245 and below to work with Hive 2 and latest Hadoop AWS jars is a dependency nightmare. And that's where the suggestion to move towards Spark 3, which has been recently released, as most of the issues with working with Hadoop AWS and Hive has been fixed in that latest release. Spark 3 is also well suited for Kubernetes, as some of the important things like dynamic allocations and external shuffle service has been added in Spark 3. And some of the critical Parquet bugs or bugs related to Parquet has been fixed with the latest upgrade to Spark 3. Below are some of the advantages we have observed running big data processing workloads on Kubernetes. The unified management of clusters across different types of workloads, say service workloads and data processing workloads, is a huge win. Containers simplify dependency management, and the data processing jobs also get to use all the tooling built around the rest of the organization, like Artifactory, CI/CD tools, etc. This also helps reduce cost as OpEx and other resources are shared across multiple different kinds of workloads. Declarative specification of data processing jobs and infrastructure make it easier for data workers to specify and manage them. Especially for ML, this is a huge win as it involves a lot of configs in some cases. These are some of the numbers that we have seen with running SpoK in production. There is around 30% of cost reduction due to better use of resources across different workloads. The dev productivity has improved a lot because of the automated CD deployments. In some cases, we are seeing it come down from week to a day, from dev to prod cycle. The operational overhead of maintaining this has reduced, especially the security patches and the cluster upgrades. Since it is done as part of the entire org, there's no need for managing them separately as part of data org. And performance-wise, we are seeing porting an application running on the previous stack on Kubernetes, we are able to get similar performance. I think we definitely see possibilities to tune the scheduler, which would help us get further benefits in the future. Having worked on a SpoK operator for data processing workloads, in future, we would like to build a custom ML operator to orchestrate ML workflow and resources through different stages of ML lifecycle, such as feature engineering, model training, and model deployment. We are hoping this operator will encapsulate and abstract the nuances of the underlying infrastructure and runtime. As we also want to expose a managed platform for self-serve of data processing jobs and their lifecycle management. Thanks for listening to us, to our talk. If you would like to chat about any of the other things, please contact us at our emails.
Look, please let us know if you have any questions. We'll be glad to answer it live.
I can see some questions. In SpoK versus EMR, can you elaborate how cost reduction was achieved? Yeah, so there were multiple aspects to the cost. One was, for example, EMR as a service has a cost of 25% additional surcharge on the underlying hardware cost over and above the underlying hardware cost, which was straight away we could avoid. And also the operational expenditure around maintaining these clusters. Since within the organization we had operationalized management of these clusters for rest of the services workload, we could build on top of that. So for example, if there was a critical security patch which had to be applied for our cluster, in the past, there were we had to do it separately. But with moving to Kubernetes as a single resource manager, all of that is taken care of by the rest. So there is a shared operational expenditure cost and also the additional EMR cost. But we also see opportunities around scheduling, or basically, optimizing the scheduler and stuff like that, which we haven't done it yet, but we think will give us more benefits in the future.
In addition to what Nagaraj said, the other reason why we are able to leverage realize cost advantages is because we're able to now join workloads together, so we can run Spark applications and other ML workloads in the same cluster, utilizing the same compute as well. So that gives us an overall cost amortization. So we don't have like islands of capacity, which is what we used to have with our EMR solutions. So while 30% is 25% is the minimum cost advantage that we got, and we've seen in some cases almost up to 50% of cost advantage.
Yes, another question. How much effort was it to move from Yarn to Kubernetes as a scheduler for your Spark jobs? From Spark perspective, I think the effort was not much, since Spark supports, at least the Spark 3 supports Kubernetes as a resource manager. I think it was around the rest of the infrastructure. For example, in our case, S3 was our data lake or our SDFS equivalent. And we had to do a lot of work to get it working with the Hadoop AWS jars, because when you run on EMR, there is a EMR file system which comes with it, which is AWS proprietary, which we cannot use with Kubernetes. So we had to switch back to the S3A file system, which is the open source equivalent of it. The other thing was EMR is a managed service which provides you things like Hive and rest of the stuff, Hive server and Hive service 2, which, since within the organization we use a centralized Hive metastore for managing the metadata, we had to build support for that. So I think these were the two big ones. And then I think a lot of the pain has been eased with Spark 3, with all this different open source components. But yeah, just lifting and shifting the existing application as is involved only these changes. I think, yeah, there's a question from Stephen. Which technical part of this migration journey was the most complex, and what more challenges did you face? I think, as I said, I think it was mostly around the rest of the infrastructure, like S3, Hive Metastore, and getting them to work with, getting all this big data infrastructure to move on to the Kubernetes world was a challenging part for us.
There's a question in the chat. So all your data accessed by Spark resides in S3 now. Yes, all the Spark data is in S3, and we have the S3A file system view, which allows Spark to access the data from S3. Just to add on to the effort question, I think it took us about 6 months start to end to actually create a fully paved road approach around SpoK, where we were able to then provision namespaces and provide security controls and so on. A lot of, as Nagaraj said, a lot of the work was around making Spark and Kubernetes work with things like namespace access and roles specifications and so on. Spark itself, we were able to get the Spark application running in a few days, but the majority of the effort was spent on operationalizing the rest of the Kubernetes infrastructure. This question: did you experience network bottlenecks with S3? Nagaraj, maybe you can take that.
Yeah. So I think there were some challenges with S3A initially, but nothing specific related to bottlenecks. Obviously, I think the EMR, there is a lot of work going on in the S3A file system related to, at least on the commit side, there are different commit strategies. But yeah, we did not face much on the bottlenecks, on the network bottlenecks.
Question
Yeah.
from Alex on using the Spark operator to deploy Spark jobs on Kubernetes. Yes, we are using the Spark operator from Google, and we're using that to deploy Spark on Kubernetes. We have a local installation of the Spark operator, and so Intuit's Kubernetes has its own controls around namespace security and so on. So we have a custom deployment of the Spark operator in our clusters. There's another question on Spark streaming. Are we running Spark streaming jobs such as batch jobs? We are running both. We have both Spark streaming jobs and Spark batch jobs running on this infrastructure. Majority are batch. There are a few streaming jobs as well. In general, for streaming, Intuit uses Beam, Apache Beam, and we have a Beam-based streaming platform. So we try to direct most of the streaming use cases onto the Beam platform. There are quite a few legacy Spark streaming applications which are starting to move to this infrastructure. Question on, as a data scientist, data analyst, what new things should they learn to work in this SpoK environment coming from the AWS EMR background? The good news is as a platform team, we've abstracted out a lot of the underlying SpoK infrastructure. So it is the expectation from data scientists is that they are familiar with Spark and they write a really good Spark code. And after they commit the Spark code, the platform takes over and the platform does the build and deployment in a standardized fashion for them. So they, from a data scientist perspective, they don't really see the underlying Kubernetes infrastructure and all the complexities that go around with it. So in addition to just having a Spark application, we had to build the CI/CD for the application so that we can provide our data scientists and analysts with an interface that was as close to what they already know, which is around Spark, and so that they can be productive with that.
Yeah. Just to add on to that, I think one of the big changes from going from EMR to on Kubernetes was the whole container journey. So which they were very familiar with because that's how they used to deploy their machine learning models. So now they can do the same thing for their feature engineering or data processing jobs. And I think since we were using most of the stuff which was already built in the organization, like CI/CD pipelines and build automation, so it's fit seamlessly into that infrastructure, and they did not have to do much apart from declaratively specifying in the YAML what needs to be done to run their Spark jobs. Yeah. I think there's a question from Max. Beam is also on Kubernetes. Yes, Beam is also on Kubernetes. It runs on entirely on the Kubernetes infrastructure.
Yeah, we have Beam running with both Samza and Flink as backends. Um, and we have again built a platform around it. So our customers who are our data scientists and analysts, they get a very simple interface to write their Beam code. And the platform takes care of CI, CD, and deploying it for them. There's a question from Sasha. Is it possible to get the slides? Definitely. We will publish the slides on SlideShare. Oh, there's a question from Max on how we manage the containers for Spark. So the question is for Spark jobs, are you preparing container for every job, or do we have a universal container which pulls the job jar? Um, it's a little nuanced. So we have a Spark based container which has all the Spark related stuff. And then what we do is during the build process, we layer the Spark job on top of that base container, and we create a new container which is versioned, very specifically versioned, and with the commit ID, and that is used to propagate through our various environments like dev, test, and production environments. Um, so the answer is yes. There is a container for every job, and this is built. It is a the it's a thin layer built from the base container of Spark. There is another variant which we are using for featureization, feature processing in the machine learning workflows, where uh, we interact with the feature store, which is in S3, and we need to run Spark application to get the features from the feature store. In that case, the feature store reader itself is a prepackaged application, and we only pass it configurations. But a majority use cases where the jobs uh, will be built. Every commit gets built and gets versioned.
Yeah. Just to add on to that, I think this was a very pleasant experience also. For example, we take the open source base Spark image, and then there's one level of overlay where we add stuff like Hadoop AWS jars or specific jars required for Metastore access and stuff like that. So that's one level of overlay. And then that is released. And on top of that, application teams can take that and just add their stuff on top of that. So I think it's because of the whole container thing, it's very easy to manage the dependency also. And whenever there's a new version of a Spark, there's a central platform team or us who are responsible for releasing the base images. And then the application teams can take that and build their stuff on top of it.
want to go back to Steven's question on what new things they would have to learn to work in the SpoK environment coming from the EMR background. One of the things that we have done with this is we've actually reduced the things that a data scientist has to learn, because they don't need to learn about how to set up an EMR, how to manage the infrastructure and write like Terraform or CloudFormation scripts. So there's a lot of things that they don't need to do, and instead they just need to focus on their Spark code, which has been the focus of SpoK. Okay, we just got a notification that we should be wrapping up. So thank you all for attending our talk, and these were great questions. Thank you so much. Would love to connect and continue the conversation. We will publish the slides and share it in the appropriate forums. So thank you so much, and please do feel free to reach out to us for any questions and any further conversations on this. We'd be glad to collaborate.
Yeah, thanks everyone.